Hello guys, welcome to my video. Today we'll be looking at a IB Math HL paper 1, and this specific paper is from May 2015 time zone 1. And in this video I'm going to look at some of the harder questions in the paper. So I'll be starting with section A and with question 8. So question 8 asks us to find the integral of this function here. So this one right here, using the substitution u equals e to the power of x plus 3. Okay, so now let's first take a look at the function. So e to the power of x divided by e to the power of 2x plus 6ex plus 13. So first, if by looking at the function, we can sort of see that the denominator of the function sort of looks like a quadratic equation. I don't know, maybe I could rewrite this in another way so that I can use the substitution that I've been given, u equals e to the power of x plus 3. So let's say I write the integral like this, and I write the denominator in the following way. So e to the power of x plus 3 squared. But of course, e to the power of x plus 3 squared is not equal to e to the power of 2x plus 6, e to the power of x plus 13. This e to the power of x plus 3 squared would just give us e to the power of 2x plus 6ex plus 9. So we're missing 4, so we can just add 4 here, right? Okay, so now I can rewrite the whole integral in this way. So I can write it now as u squared plus 4. And there's dx here, and there's dx here. Okay, well, if I let u equals e to the power of x plus 3, then I know that du over dx would still be e to the power of x, sorry, and that du, because we're writing the function in terms of u now, we know that our dx would be du over ex. So the integral can again be written as e to the power of x divided by u squared plus 4 times du over ex. I know here we see that the ex's cancel out, so we get the integral of 1 over u squared plus 4, which is, now we're going to have to find the integral of 1 over u squared plus 2 squared. And using our formula booklet right here, we see that, oh, hey, let's see, 1 over a squared plus x squared dx, integral of this, I mean 1 over a arctan x over a plus c. So we can use this, and we know in this case a equals 2. So, oh, sorry. So the actual final answer is going to be 1 over 2 arctan e to the power of x plus 3 over 2 plus c. This is the final answer. Hi guys, so now we'll be moving on to the next question, which is question 9. And in question 9, we're given two functions, fx and gx. Sorry. And fx is 2x plus power 5, and gx is 3 sin x plus 4. So question 9, asks show that g of fx is equal to 3 sine 2x plus power 5 plus 4. So this basically means that we're going to put fx into gx. So now we just get 3 sine of whatever fx is, which is 2x plus pi over 5 plus 4. And that's it. In part B of question 9, we're now asked to find the range of this function here. So we need to find the range of 3 sine 2x plus pi over 5 plus 4. And we know that the maximum value of this part of the function is going to be 1, and the minimum value of that function is going to be -1. So now we can work on the range. So if you want to find the max of the range, we just do 3 times 1 plus 4, which is 7. And now with the lower bound of the range is going to be -3 plus 4, which is equal to 1. So we know now that the range of g of f is going to be it's going to be written as this. Moving on to part C of question 9, we are now given that g of f when x is 3 pi over 20 is 7. And now we want to find the next value of 7, which is bigger than 3 pi over 20, for which this is going to be equal to 7. So we know that the x is going to be 3 sine 2x plus pi over 5 plus 4. And we know this is equal to 7. And find the next value of x, which is, so this is equal to 7. So 3 sine 2x plus pi over 5 plus 4 is equal to 7. So from this, we know that 2x plus pi over, I'm not going to skip over any steps here. 3 sine of 2x plus pi over 5 is going to be 3. So sine of 2x plus, not 5 over pi over 5, sorry, is equal pi over 5 is equal to 1. So we know that 2x plus pi over 5 is going to be equal to pi over 2 plus 2n pi, and we put the 2n pi here because if you look at the sign graph, it repeats every 2 pi. So solving this equation, we get x equals 3 pi over 20 plus n pi. Now when n was 0, x would be 3 pi over 20. So we want the next value of x that would give 7. So we let n equals 1. So then therefore x is going to be 23 pi over 20. Moving on to part D of question 9. Now we are asked to transform, so we're asked the steps of transforming y equals sine of x to this function here, right? So we want to transform. So the first thing that we're going to do is we see that there is a stretch, there's a vertical stretch by a factor of 3 because of the 3 here. So there's a vertical stretch by a factor of 3, 3 here, which would give y equals 3 sine of x. And then what we see is that there is a vertical translation 4 units up because of the plus 4 right here, 4 units in the positive y direction, which would give y equals 3 sine of x plus 4. And then what we do is, okay, now we look at what is inside here, what is inside there. So we see that there is a 2 here, and this corresponds to a horizontal stretch by a factor of not 2, but 1 over 2, so the half, which is going to give us y equals 3 sine of 2x plus 4. And the last thing we can do is we say that there is another horizontal translation pi over 5 units to the left. Moving on to question 10, we now have a football team, and we will just call this team A. And Team A goes on to play a football tournament where there are 5 matches, and the probability of them winning one match, the probability of winning per match is going to be 1.5. The probability of them drawing is 1/6, and the probability of them losing is going to be 1/3. Now, the boss of the club isn't too happy with the coach, and he says that if the team loses 3 consecutive matches, the coach will lose his job. So now it is up to us to find what is the probability of the team losing 3 consecutive matches. So I'll just do the question, and we have 5 matches, so we can draw this as like match 1, match 2, match 3, match 4, match 5. Now there are a couple of scenarios. There are 3 scenarios in which the team can lose 3 consecutive matches. So in scenario 1, we say that the team loses the first 3 matches. And we do not really care about what happens in the 4th or 5th match, because losing the first 3 matches already ensures that the coach is fired. So we don't really care what happens in game 4 and 5. So the probability of the team losing the first 3 matches is going to be 1/3 cubed, which is simply 1/27. Now scenario 2, again, we have the 5 matches, and instead of losing the first 3 matches, the team loses match 2, match 3, and match 4, which is these matches. And in the first match, we definitely cannot lose, because if they were to lose, then we would be just jumping into scenario 1 again. So, and the probability of not losing is going to be 1 minus 1/3 from here, which is going to be 2/3, which is going to be, so the probability of this scenario happening is going to be 2/3 times 1/3 cubed, which is going to be 2/81. And again, we don't care what happens in the last game, because losing 3 consecutive matches is already enough for the coach to be fired. Now, final scenario, we have, again, 5 matches, and we say now we lose the last 3 matches. Now, I have to be careful here, because we can still lose the first match, because if we lose the first match, so if you lose the first match, so L here, for example, and we draw in the second match, we still have 3 consecutive losses, so we'd still lose our job. So, it doesn't matter what the outcome of the first game here is. It can be anything. So we don't care. So this probably just being 1. Now we know that the second match, we only want 3 consecutive losses. We don't want 4. So we just put the probability of not losing in the second game is going to be 2/3. So the final probability of scenario 3 happening is going to be 2/3 times 1/3 cubed, which is 2/81. So the final answer is going to be, the probability of 3 consecutive losses is going to be 2/81 plus 2/81 plus 1/27. Yes, which is going to be 7/81.